when it comes to start learning engineering mathematics, or for that sake any other mathematics, one of the most important topics that a student should be knowing is integration. Lot many times in lot many lectures I have already discussed that integration is a crucial topic. So our today's discussion is going to be based on understanding what integration is. I welcome you all to my channel Pankaj Lade. Make sure that you subscribe to my channel, hit the like button and share the channel as much as possible. So let's understand first of all what geometrically integration means. Many of the times a student usually does not know what integration actually is. So our first session will be entirely based just to understand geometrically what integration means. For that, I would consider a simple example of a line. I hope everyone knows what is the equation of a line. Let us say, if I give you the equation of a line as x plus y is equal to 1. It's a very simple equation. X plus y is equal to 1. So, this equation, if I want to draw on a graph, it will be looking something like this. So, this is the x-axis, this is the y-axis. When I put y as 0, if I put y as 0, x is going to come 1. That means there is a point 1 comma 0. If I put x as 0, y is going to come 1. So the point is 0 comma 1. That means you can definitely say that the line x plus y equal to 1 passes through the points 1 comma 0. I'm going to name it as point A, and 0 comma 1. Let us name it as point B. So if I draw a line now, it will be passing through the points A and B. So that's my line AB, which is passing through the points A and B. Its equation was x plus y is equal to 1. Now, this line can be considered as a curve. Integration is basically area under the curve up to the x-axis. Listen to the definition one more time very carefully. I said integration is the area under the curve up to the x-axis enclosed within some vertical boundaries. Area under the curve up to the x-axis enclosed within some vertical boundaries. Observe here. This is the line. I said area under the curve. So line is taken as a curve. Area under this curve up to the x-axis enclosed within vertical boundaries. I will draw the vertical boundaries here. Observe this. This is the vertical boundary. This vertical boundary is along the y-axis, and we all know that the equation of the y-axis is given as x equal to 0. Further, at point A, if I draw another vertical boundary, this line is a line parallel to the y-axis. Its equation is going to come x equal to 1. Then, what do you mean by integration? It is the area under the curve up to the x-axis enclosed within some vertical boundaries. So this is the area under the curve. Now, we very well know from geometry, this looks like a triangle OAB. And if I ask you to get the area of triangle OAB, so area of triangle OAB, is it a right angle triangle? Because we know that the x and the y axis are at right angles to each other, so it's a right angle triangle. So area of a right angle triangle OAB, it is going to be half into product of perpendicular sides. Half into product of the perpendicular sides. So it is going to come half into, this is 1, isn't it? Perpendicular sides are OA and OB. So it is 1 into 1. The answer came half square units. So this is from geometry we have understood that the area of a triangle OAB is half square units. Now let us try and understand the same concept from integration. Now, integration, as I said, it is nothing but area under the curve. But how do I get this area? What I will simply do here is, this area under the curve, I will divide into very small rectangles. I'll divide into very small rectangles. So as such, I can draw infinite number of rectangles. The area under the curve is divided into infinite number of rectangles, small rectangles, infinite number of rectangles. And if I do the sum of the areas of all the rectangles, all these infinite rectangles, if I add all the areas of these rectangles, I'm going to get the area of the triangle, isn't it? So I can write here area of the triangle OAB is equal to the sum of infinite rectangles drawn under the curve, isn't it? Now people understand this sum that I have written, it has S, the sum, this word begins with the letter S, that is the sign of integration. So I will write S here. So integration is nothing but sum of infinite rectangles drawn under the curve. Now, what is the basic idea of integration? Let us try and understand that. I have the equation x plus y is equal to 1. From here, can I say y is equal to 1 minus x? Isn't it? I can say y is equal to 1 minus x. So integration of 1 minus x and dx. Do not worry what basically the formulas are. We are definitely going to see how the formulas are derived, what those formulas are in our upcoming lectures. So right now, just for argument purpose, let us say integration sign is nothing but s from the sum and it is accompanied with the dx, and then I have the function y is equal to 1 minus x, which is the equation of the line. So I have written 1 minus x. Now, as I said, right now let us not worry how this formula came. Just for the sake of explanation, we are taking integration of x raised to n dx as x raised to n plus 1 upon n plus 1. We will definitely be looking at these formulas in our upcoming lectures. So, integration of x raised to n dx, I am writing it as x raised to n plus 1 upon n plus 1. So, if I ask you integration of x raised to 0, if I ask you integration of x raised to 0, that means it is 1, x raised to 0 we know it is 1, so integration of 1 dx. If I apply this formula, the formula tells me to write x raised to 0. N is nothing but 0. So you start replacing n with 0. So I get x raised to 0 plus 1. That is x raised to 0 plus 1 upon 0 plus 1. So the answer came x. That means I can say integration of 1 dx came x. Isn't it? Integration of 1 dx came x. Likewise, if I try to get the integration of x, let us try and get the integration of x. So here I can say the power of x is 1. Again I go back to my formula x raised to n. The formula tells me to write the answer as x raised to n plus 1 upon n plus 1. So I am going to write here x raised to n plus 1. So I get 2 upon 2. So that is the formula of integration of x dx. Let's use these formulas in our question here. So I am going to get my answer. Integration of 1 is x minus integration of x is x square upon 2. Now, do you remember, I have already told you that integration is area under the curve within some vertical boundaries. The boundaries were given from x equal to 0 to x equal to 1. These are called the limits of the integration. These are called the limits of the integration. X equal to 0 to x equal to 1. So I am going to put a bracket here and then write x equal to 0 and x equal to 1. This x equal to 0 is called as the lower limit and x equal to 1 is called as the upper limit. So now if you substitute the upper and the lower limit, let us see what happens. So if I put the upper limit, which is 1, so I am going to put x as 1 here. So x is 1 minus of, I put 1 square upon 2. That was the answer for the upper limit. Let us put a bracket. Then let's put the lower limit, which is x equal to 0. Obviously, when I put x as 0 here, I put 0 here. The ultimate answer is going to be 0. I close the bracket. So I get 1 minus half. 1 minus half is simply 1 by 2. So did you observe? I started with something called as an integration and my answer came 1 upon 2. What did I integrate? I integrate the function 1 minus x. Where do I get this function 1 minus x? It was the equation of the curve. So ultimately I observed that integration has simply given me the answer half, which is actually the area of the triangle that we have already obtained from the concept of geometry. That means from here I can say that integration is basically area under the curve, isn't it? So people, whatever concepts I have told here, we will definitely be discussing what these concepts are, what these formulas have come in my upcoming lectures. Keep watching. So I hope you have basically understood what integration means, what the basic definition of integration is, what the geometrical aspect of integration was. Now the mathematical aspect definitely we'll be looking at in our next lecture. Make sure that you keep on watching. Thank you so much for listening me out. Have a great day ahead.